Hi, welcome back to my channel. In this video, we will be having a discussion on the basic set theory for kids. I made this topic available for kids because I want young minds to understand the importance of learning set as one of the foundations in pursuing higher mathematics and learning facts in math to avoid ambiguity and misconceptions such as the fact that we cannot divide any number by a zero. So what is a set here? Well, a set is a well-defined of collection of object. So take note of the word well-defined. So this is the key word. This is not just a mere collection, but a well-defined collection. That is, if we are going to identify if a certain collection is a set, then we have to make sure that we will be able to identify what are in it. Okay, let's consider, for example, let's say this is a collection of numbers 1, 2, 3, 4, and 5. So this is a set because we can identify that the things inside in this is 1, 2, 3, 4, 5. Okay. Another thing is, let's consider this. A collection of the vowels of the English alphabet. So this is a set because we will be able to identify what are the elements in it. So things that are in this set are A, E, I, O, and U. So which means that the element, that things that are in it are actually well-defined collection. Let's consider these. A collection of beautiful places in the Philippines. So this collection is not a set. Why? This is not a set since this is not well defined. Take a look at these beautiful places. So let us say, for example, one person would say one of the beautiful places is Boracay. It may be a beautiful place for somebody, but it may not be a beautiful place for anybody. So that means that this is not a well-defined collection because the beautiful places is actually so vague that one may be beautiful for, this thing may be beautiful for the others, but maybe not beautiful for the others, something like that. So therefore, um, in order for us to present a set, we have to make sure that everyone agrees that that set contains a certain collection. Okay. Well, when we talk about the set, a set can be written into styles. Number one is we have the roster method. Number two, we have the rule method. Okay, so what is the difference between the two? So let's just present a keyword here, roster, which means we have to be very specific of all the elements inside a set. Rule, on the other hand, is general. So this will be, we are just making enumeration on the roster. And for the rule, we are actually presenting it by, let's say, a variable. And that variable, we have to describe it to make sense of a set. Let's say, for example, this is our collection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in order for us to write that collection in a roster method way of writing a set, so we can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will separate them by commas and we will place this in braces. So that's it. So we are only enumerating the elements inside a set. Now, for how do we write that for a rules method? So we will just use the same. We will use the braces, but this time we will use a variable. So let's say we write a variable x, so depending on your choice, but this time you'll have to make a rule for x in which that will be described based on what is really the collection. So your x, so you define what your x is, so such that, so this one is read as such that, or sometimes it is denoted by this, such that. So x, such that x is an integer from 1 to 10. So that is a rule method. Now, upon looking to this specific example of a set, if you notice, you will find the a number 1 in it. So that means we can say 1 is an element of a set. So meaning to say that an element, that A is an element of a given set if A can be found in the collection of that set. Now, usually our set will be denoted by capital letters. It might be a Greek symbol, depending on your choice, as long as you can be able to identify that. Now, on the other hand, mostly, it's not really the general, but mostly elements of the set are represented by a small letter. Okay, now, let's say, for example, here, 1 is an element of a set. So we write 1 as an element of a set. Let's say, let's denote this set as set A. So 1 is an element of A. Now, if you notice, you don't find here 11. So therefore, 11 is not an element of A. And we write this symbol. That's it. Now, observe that a set is a well-defined collection. So let's consider, for example, that is very, let's say, let's have to be very common. Let's say this is a house. Assuming this is a house, I'm not representing a circle here, but it's a house. So inside a house is David, Jean, Kyle, Mary. So this means that this is the house, a set H. So meaning an H is a well-defined collection of people in it. So this means that David is an element of H of the house, and Mario is not an element of the house. Now, I have one question. What if these people here, David, Jean, Kyle, and Mary, will go out of the house? So assuming that these people will go out of the house. So this is now your H. Is this house still a set? Yes, this is still a set. Remember that H or the set is a well-defined collection. So that means we defined H to be a collection of people in it. Now, you cannot find people here, but still you're counting. So that means it's a well-defined collection. It's just so happened that there is no collection at that time. So that means H here is empty. So instead of writing this as just H as a representation of that set, we denote an empty set by this, or sometimes we denote this by this. That means it does not have an element in it. Now, another question. Since this one here is a symbol for empty set, this thing here is also another symbol of writing an empty set. My question, is this an empty set? No. This is no longer an empty set because this set contains a symbol for empty set. So that means the symbol empty set is actually an element of that set. So the entire set is no longer empty. It has one element which is denoted by a symbol empty set. So that's it. Now, how about this thing here, cardinality? Cardinality is defined as the number of elements in the set. So when we say the number of elements, when we say elements, it's actually unique elements. So say, for example, you have a set A here containing 1, 2, 4, 3, 3, 6. So these three here should only be written once. So that means this is just one element here. So the cardinality, we denote the symbol for the cardinality of A as cardinality of A. So it looks like an absolute value, but it's not. So the cardinality of A is 1, 2, 3, 4, 5. So that's 5. That's it. Okay, so let's talk about subsets. Okay, so given sets A and B, we say A is a subset of B denoted by A subset of B if all elements in A are in B. So this is just basic that we can say that A here is a subset of B. So we denote this symbol if all elements that you can find in A should also be found in B. So let us say, for example, I have M here, the set M containing 1, 2, 3, 4. I have the set N here containing 1, 2, 5. I have the set B here containing 1, 3, 4, 7. Now, if you notice, all elements in M, 1, 3, and 4, you can also find that in 1, 3, and 4 here in P. So this means that M here is a subset of P. Now, N, on the other hand, although it can take, although the cardinality of N here, so if you notice, the cardinality of N here is 3, the cardinality here of P is 4. So meaning to say that the cardinality of P is larger or is greater than the cardinality of N. It does not, it's not sufficiently tell us that N is a subset of P. Why? Because if you notice, the number then the elements of N are 1, 2, and 5. P, on the other hand, contain only 1. It does not have 2 and 5. So therefore, there's no N here. There's no way to tell us that N is a subset of P. So we denote the symbol. That means it's not a subset. That's it. So this is all for now. So thank you so much for watching. So this is just a basic set theory, set notions for kids. We will continue in the next video on this particular topic for a set theory for kids. So just hang on there and please subscribe to my channel. Thank you so much for listening.